Alright guys, so following a smooth horizontal wedge of mass 3M. Smooth is a good thing to see because you know there's no friction. It's a big sigh of relief when you see smooth. Of mass 3M rests on a smooth horizontal surface, so you see two smooths, you're really happy. Okay, it means it's smooth for the particle, for the wedge moving, and it means it's smooth for the particle moving on the face of the wedge. Two smooth motions, okay? One face of the wedge makes an angle of 45 degrees. Also be thankful when you see 45 degrees because you can't get it wrong. Because even if you use the other angle, it's also 45 degrees. If that was 30, sometimes people get mixed up between 30 and 60, which can happen sometimes. But because it's 45, very unlikely to make an error. So this is a very nice question. Alright, a particle mass M is placed on the smooth inclined face of the wedge. The system is released from rest. This is something that people don't do sometimes, and I'm guilty party of this as well. Separate diagrams. So what do you notice about the marking scheme? The diagrams are completely separate from each other, aren't they? Now, that's not how I traditionally do them. I actually do them all in one diagram. But for the sake of the marking scheme, when it says separate diagrams, do them separately, okay? So I do my usual R supports it, going R is always perpendicular to the surface. Everybody cool with that? And weight always goes where, guys? Straight down. And you resolve weight parallel and perpendicular to the plane. So this is perpendicular and this is parallel. We all cool with that? So R is technically balanced by this part here. Now we know it's 45 degrees, don't we? So it's mg cos 45 and mg sine 45. We all cool with that? Which is mg over root 2 and mg over root 2. So R would equal mg over root 2. So for those who didn't hit that, that one always equals that one. Okay? So what we're going to go for is okay, mg over root 2, mg over root 2. Okay, we all on board so far? Now, failing what we're saying is you have to show opposite diagrams. Now, do you notice for the wedge there's no mention of any of the mg's from the block? Why is that? It's only experiencing the reaction force R that's equal to its weight going downwards, okay? And it's also only experiencing the reaction force R1 from below, okay? And 3mg obviously going straight down. Is that okay? And obviously the particle itself only experiences a reaction force R and weight going downwards. So it's not half as complicated as the graph we usually do. Okay with that? Alright. Now what way are we going to have this particle, what acceleration are we going to use for this particle? Can anyone tell me? Pick a letter and stick to it. Is it going upwards or downwards? If it was stationary, it'd be going downwards, okay? And usually they always go downwards. Is that okay? And what about here? Call it B. Okay? Now, oh sorry, I'm actually not allowed to do that. P and Q. P and Q. All good so far? Now, here's what we're going to do next. You can go parallel and perpendicular to the surface, alright? So let's go parallel to the surface. What are the forces acting on the block? Force equals ma, which means ma equals force. What force is forcing the particle downhill? mg over root 2, which is here. Is that okay? Is there any friction involved? If there was friction, what would you do? Minus the coefficient of friction multiplied by the R value. The R value is also mg over root 2, and it'd be acting against the motion. Is that okay? Be acting against the motion. So just mg over root 2 going diagonally right down. And what's the weight of the particle again? Just m, isn't it? Is that right? Made a mistake. Not as easy as that. Anybody know the mistake we made? Definitely not as easy as that. Man, what's it? We did it as if if we did it like a plane. That's not a plane. What is it? A wedge. Wedges move. So what did we forget to do? We forgot to break up the wedge's acceleration parallel and perpendicular to the plane. That's where the mistakes kick in. People treat it like a plane when it's actually a wedge. So Q is here. What's this? 45 degrees. What's that make this part here? It's 90 degrees. Anybody? Q over root 2. And this one here. So we're all right with this, but where we messed up was in the acceleration part. It's m. Now what acceleration goes diagonally left down? P. But what's opposing that? Q over root 2. If you look at this part here, it's going in the opposite direction. Okay? So this Q over root 2 becomes significant. Remember, wedges are never that easy. Sorry, that's shocking writing. Alright, we all good with that? Okay, that's parallel to the plane. Now we can strike off the m's, can't we? You could multiply both sides by root 2 as well. And what happens there? Root 2p minus q equals g, is that right? Multiply both sides by root 2. And value. Right. Now what about the next one? We're going to go perpendicular. And you'd be like, but the particle only has acceleration parallel to the axis. Why are we even considering perpendicular? What's the deal there? It's travelling on an object that is moving, and this object, when you break up its components, has a perpendicular component. It's q over root 2 diagonally right down. So once again you go ma equals f. We know the f is going this way and the a is going this way. So it's going to be m times q over root 2. Now what are the forces in this direction? The perpendicular direction. Can anybody see them? What are they? Yet again, earlier I said something and I have to re-explain it. Remember I said the two of them are equal to each other? That's not the case. Can anybody tell me why? On a flat surface they're definitely equal to each other. So example is if I had reaction force R and I don't know mg over root 2 going down, why are they equal there? The ground itself isn't moving under the weight of the particle. Because the wedge is moving, obviously something's giving way here that they aren't equal to each other. Because the ground is moving from underneath you. Okay? So therefore on a slanty surface the two green parts aren't equal to each other because the overall acceleration needs to be 0 for them to be equal to each other. Is the acceleration 0? No, it's not. Alright? So sorry about that earlier. That was a slight slip on my part. Now, mq over root 2, and then what do we have here? mg over root 2 going diagonally right down, and r going diagonally left up. Alright? What's the problem with this equation? Introduces r. The other one has no sign of an r. It'd be interesting to see if we even needed this equation whatsoever. Did we even need it? I don't think we do. Alright? Let's go for the last equation, which is going to be the wedge itself. Okay, so I'm just going to reduce this, and I'm going to leave it in the corner. I don't think we'll need that because it's 3 variables, isn't it? We now have P, Q, and R, which is 3 variables. We might need it. We'll figure this out. All right, back to the wedge. Wedge only. What did we say was driving the wedge forward? Huh? Q. What's the force that's causing that wedge to move that direction? Ah, so we do need R. So it is a relevant equation. Okay. And what happens when I break up its components? That's 45. That's 45. Therefore, that's 45 as well. So what does that make the 2 R components? R over root 2 and there's no friction, right? So what does that mean for this equation? Once again, ma equals F. What direction is the acceleration going in? Directly to the right. What's the mass of the wedge? 3m. Acceleration Q. And what do we have here? R over root 2. We cool with that? We could multiply both sides by root 2. And what do we get then? 3 root 2 mq equals R. You alright with that? Now, what can I do with this equation, the red equation up here? What can I do right here? Sub in R. Okay. What's a 3 root 2 mq? The m's are gone, aren't they? Multiply across by root 2. And we get 3 times root 2 times another root 2, which is 6q. Bring it over to the other side. 7q equals G. And q equals G over 7. We cool with that? Go back up to the black equation. If q is G over 7, you're going to get root 2p minus G over 7 equals G. Root 2p. Sorry, the p is not in the square root sign, it's root 2. So it's, what's that, 8g over 7? And then p on its own is 8g over 7 root 2. You bring the root 2 underneath. 8g over 7 root 2. Okay, check the old marking scheme. 8g over 7 root 2 is correct, and g over 7 is also correct, and that was worth 25 marks.